Hello all. In this video, we'll talk about Heapify. In the last video, we spoke about heap sort, right? We basically sorted an array using heap sort algorithm. So what are the steps we followed in heap sort algorithm? One is initially we created heap and then we deleted elements one by one from the heap. For creating heap, what did we do? We inserted elements one by one. What we have done is we took 90 and we created heap, and then we took 23 and then we created a heap. We took 5, we created the heap. So we followed the process by inserting the element one by one. And for insertion process, what you have done, for insertion process, you inserted element at the bottom and then you pushed element like this to top. You have followed downward direction, like from bottom to top you have followed. You added element at the bottom and then you pushed element to the top. That is what you have followed in insertion. And for deletion, what process did we follow? Whenever you deleted an element, like here if you see, I deleted 109. Let's suppose I delete 109. What is the deletion process we should follow? I should take the last level rightmost element and add it here and then remove this. Basically, you have to swap this. Okay, this is what we have followed in the deletion process. Once we have done, what did we do? We compared this root node with its children and then we started swapping it. Like we started swapping in the downward direction. So here for the deletion, we are doing the downward direction, and for insertion, we are going in the upward direction. So directions of insertion, inserting an element in a heap and deleting an element from the heap are opposite. Now, say here if you see the time complexity of the heap sort algorithm is order of n log n, right? For creating the heap, we got n log n, and for deleting the elements, we got n log n. Using Heapify, we can modify this creation time complexity. Now the creating the heap time complexity is order of n log n, right? We can change it to order of n. We can do some optimizations. So let's talk what is a Heapify process. We remember the deletion algorithm, right? So we follow the same thing here. So in the deletion, what we have done, so in the deletion, only one element, only the rootmost element is not following the heap property, and its right child, complete left subtree and the right subtree are following the heap property, because here 90 is greater than 23, 12, 67 is greater than 5. So except the root element, the left subtree and the right subtree are following the heap property, and only the node is not following the heap property, and we did adjustments by pushing it in the downward direction. So the same process we follow while creating the heap also. So for that, what we should do is we should start building a heap from right to left. So while creating the heap, we did like this, right? Using insertion method. Now use for Heapify, what you have to do is you have to follow like this. You have to go from right to left, and for each element we form a heap and then we arrange it. Let's see how you do that. Now first I take 34. This is the tree that was formed using the array, right? Now 34 is a heap because this is a leaf node, and even 12 is a heap because this is a leaf node, because it don't have any left and right children. A single element is always either a minimum heap or maximum heap. And 22, it is a heap because it is left, it doesn't have any children. Even 67 is a heap. Okay, now what we understood is a leaf node is always a heap. You need not do any adjustments on the leaf node. So the only thing we have to work on is internal nodes like this. Only these 4 nodes are the internal nodes. We have to adjust only these internal nodes. Okay, now let's start doing that. For 109, I'll start with 109. Is 109 following the heap property? So just remember the deletion algorithm. So 109 is greater than 34. Okay, then I need not swap it. 109 is greater than 34, right? I need not swap it. Now this is a heap. 109 is greater than 34 and this particular part is heap. and this particular part is heap. Now I'll go to 23. So 23, if you remove the if you remember the deletion algorithm, left subtree and the right subtree are already heaps. Only 23 is not heap because 23 is lesser than 109. So what you have to do here, you have to compare it with its left and right subtrees and then you have to swap it. Okay. Now what I have to do, I compare 23 and 109 and 23 is lesser than 109, right? I have to swap it. Less 23 is lesser than 109. I have to swap it. 23 done. Okay. Now 23. I compare 23 and 34. Like 23 and 34 here. Both comparisons. Here 23 is lesser than 34. I have to swap it again. So I'll swap these both 34 and 23. So after this complete tree subtree is a heap, right? Because 109 is greater than 34 and 12 and 34 is greater than 23. So this complete subtree is a heap. Okay, and the process we followed is we just followed the deletion algorithm. Okay, now let's come here. Anyway, this 22 and 67 are leaf nodes and it is following the heap property. Now let's talk about 5. I'm considering only this heap. I'm not considering any left one or in 90 anything. I'm just concentrating on this one. Now if you remember the deletion algorithm, fifth value is lesser than 22 and 67. What we should do, whichever is largest between 22 and 67, I should swap it, right? So I'll swap 67 and then I'll add 5 here. Okay, now if you see, even this one is a heap. Even this particular right subtree is a heap and this left subtree is also a heap. Okay, now let's go to 90. When you go to 90, 90 is lesser than 109. So it's not following the heap property. And you follow the same process as deletion algorithm. You keep swapping it 90. So you swap both. What I'll do here is I'll swap 90. And when I go down 90, when I compare 90 and 34, 90 is its at right place. 90 is greater than 34. So you need not do any swapping. Now if you see, it is a complete maximum heap. 109 is greater than 90 and 67. 90 is greater than 34 and 12. 67 is greater than 22 and 5. 34 is greater than 23. So we have created a heap using Heapify algorithm. And how many nodes did you consider? For arranging it? You ignored leaf nodes, right? You just arranged the internal nodes. If you see here, leaf nodes are already heap. You did not make any modifications to that. You made modifications only to the internal nodes, and for each internal node, maximum time complexity it takes is order of nlogn. For each internal node, maximum time complexity is nlogn, because the worst time complexity is when you have the root node, you have to push it till end, right? So for that, the maximum time complexity is nlogn. Okay, that's it. Now, how many nodes you have to make adjustments? See, since you ignored the leaf nodes, the maximum internal nodes that can be present in a tree is 0 to n by 2, where n is the number of nodes, 0 to n by 2. So, you reduce the number of nodes on which you have to work on. In the insertion algorithm, what you did is, since you have you have followed this direction, downward direction, upward direction, you worked on each and every element and you keep pushing the element from bottom to top. Whereas in this algorithm, what you have done is you need not work on the leaf nodes, and this part, whatever the leaf nodes, and these 4 nodes you have ignored. You worked on only the internal nodes, means 0 to n by 2. So analytically, if you calculate the time complexity, n log n for n by 2. So let me write here. So log n for n by 2 nodes, right? So n by 2 log n. So if you calculate analytically the time complexity, it would be n. It should not be it should not be n log n. So here we have reduced the time complexity of creating the heap using the Heapify algorithm, right? So if you recap about this, in a heap sort algorithm, when you are doing a heap sort, what we have done, you have built a heap and then you deleted elements from the heap one by one. So creating the heap using insertion algorithm took nlogn time. So to modify that, what we have done is we have followed the heapify process, which is same as deleting an element from a heap. And using that process, we did not work on leaf nodes. We worked only on adjusting the internal nodes, which ranges from 0 to n by 2. Because of which the time complexity got reduced from n log n to n. Yeah, that's it about heapify. And these are all the technical concepts we discussed about the heap. One is, in when we started off this playlist, we spoke about a perfect binary tree and then complete binary tree, and what a heap is. A heap is nothing but a complete binary tree in which it's a complete binary tree in which there are two kinds of heaps. One is the maximum heap and the other one is a minimum heap, right? In the maximum heap, node value is greater than its children. And then we spoke about the operations that we can perform on a heap. One is insertion and the other one is a deletion. For insertion, what we have done is we followed the upward direction. We inserted element at the end and then we pushed element to the top like this. And for deletion, we followed the downward direction. We compared the element with the child elements and you pushed down. So this is the process we have followed, and then we went to heap sort. For heap sort, we created a heap using insertion algorithm, and then you deleted the element. And when you store the deleted elements and put it in the array, automatically the heap is sorted. So to make more further modifications, what we have done is, for creating a heap, instead of following this insertion algorithm, we followed heapify algorithm, which is similar as deletion or deletion operation in a heap. And in that you worked only on the leaf nodes and the time complexity reduced to order of n. And we will solve more problems related to the heap, in which we'll get better understanding in the upcoming videos. Thank you.